So next up we have Tracy and Leah, and they're going to talk to us about killer bugs and how to squash them.
Cool, thank you. Okay, great. So killer bugs, what are we actually talking about? We're talking about clinical safety today. Sounds a lot more exciting than the title we came up with. So clinical safety is super important to both of us. We work in testing medical software, so it's kind of one of the primary things that we have to think about when we're testing. So what you're going to learn today, you're going to learn what is clinical risk? What am I talking about? How do you grade it? What do we count as acceptable? How do we decide if this is an acceptable risk? We can release the software in this state. How do we embed clinical safety? How do we embed thinking about clinical risk in our test team, which Tracy is going to run through? And what kind of strategies have we put in place to mitigate risk, to identify it, to minimize the risk in our testing? And then at the end of this session, we're going to play a little game where everyone here is going to do some clinical risk assessments, grade some of these bugs, and decide, is it OK to release this bug to production or not? Cool. Ooh. Skipped ahead. So who are we? I'll do this very briefly. I'm Leah. I'm not actually a tester. I'm an interloper. I'm a product manager at Medisoft, and I wear a lot of hats. So I do a bit of user research, requirements gathering, design. I've done a bit of testing, all sorts. Tracy.
I'm a tester. My background is not testing. I didn't fall into it like most people. I actually researched it and was like, I want to be a tester. So I've only been doing it 3 years, started at Medisoft and stayed there because I love it. But yeah, I was a dental nurse for a few years, for about 8 years before that. And then before that I did admin. So my background is in kind of medical, but I won't call dental very medical.
Tracy downplays herself as usual. And who are Medisoft?
Well, Medisoft is a leading ophthalmology EMR system. So basically hospitals have our system in their ophthalmology departments to do eye operations, and they basically put all the information from our customers into that system, and that is what we produce, and we try and make it as nice as possible for them to use. The company itself has been going for over 20 years. I keep forgetting that it's in the 90s.
Yep.
I always forget the exact date. It's part of a bigger company, so we're part of Heidelberg, and there are a parent company who are based in Germany, and they actually do the machines and stuff that do the eye scans. So they bought us because we do the software, so we kind of integrate with their machines as well, which is really cool. But yeah.
Yeah, so we're used in lots of like NHS trusts around the UK with the leading provider, but we're also in like private settings. So a lot of the time now for your eye surgery, you actually go to a private hospital, even if you start out being referred from the NHS. And then we're used across Europe as well, which will definitely come up later in the talk. We're used in various French and German speaking countries primarily, and then a few private settings around the world use our system in English. And this is us having a lovely time in Paris.
Yes.
Yes. Cool. And also just wanted to point out, it's come up loads of times in talks today, we're obviously primarily approaching this from a test and a analysis product side of things, but obviously all of our teams are cross-functional. We're working closely with developers. Clinical safety is only really embedded if like everyone is working together. You're getting this kind of same mindset in all of the roles in the company. Cool. So what on earth is clinical safety? We'll get straight to it. Here's a wall of text. This is an NHS England definition, but I quite like it. There's a couple of important things in here that I want to highlight. But I don't know how to highlight them.
Oh, it's doing it along, but it's not highlighting.
Oh, it's not doing it. OK, never mind. So what I was going to highlight was the word unacceptable. So clinical risk, obviously, and clinical safety isn't about eliminating absolutely all risk. There's no way you can do that. There's no way we'd manage to totally avoid any risk when we release software. It's kind of inherent in the nature of a patient medical record that there's going to be some risk. It's just about deciding what's acceptable or not and like eliminating what's unacceptable. And then the other thing I was going to highlight was the final sentence. It's really easy when thinking about clinical safety to get distracted by kind of other problems, to think, oh, there's a problem with the there's another bug here, it's really difficult to use, this will be bad for information governments, we couldn't report on this. It's easy to get sidetracked and kind of not be thinking purely about the clinical risk aspect of the problem. Yeah. Cool. So how do we calculate risk? So the risk score is the severity times likelihood. It's a pretty easy calculation. By severity, I mean how bad is the consequence? What's the really bad, dodgy clinical safety thing that could happen here? And then how likely is it to happen? So this is how we figure out severity. I've made it colourful and added cartoons to try and make it fun. Even though it ends with multiple death. Down the bottom at the Mr. Bump end, we've got some more minor things that could happen. Just slight upset, minor injury, which you would recover from quickly. Even inconvenience. By that we mean to the patient, not to the user. That's also something that's easy to get distracted by. The primary users of our software are clinicians, not patients. We have a limited amount of patient-facing software, but primarily it's clinician-facing. So it's easy to think, this is an inconvenience, but if it's an inconvenience to the clinician, that doesn't necessarily mean it's an inconvenience to the patient. So there's not a patient clinical risk there. Then we go up through several layers, obviously getting more severe in injury, and also there's an aspect of what is the recovery like. So you've got minor injury where you'll recover, then you've got minor where you won't recover or not in the short term, and then severe where you'll recover quickly, and severe where you won't recover quickly, and then permanent life-changing incapacity or death. So obviously in ophthalmology, it's quite hard to kill someone in an eye operation. It can be done. I'd say the most risky element of our system is probably allergies. Yeah. If you mess up allergies, you can kill people. But we certainly do fall into the permanent life-changing incapacity category more easily because losing an eye and blindness counts as that. On the far left-hand side, we've got patients affected, single or multiple. So just to clarify what that means if there's a bug or a design issue, does it affect one patient at a time, or by its nature, does it affect multiple? Obviously, if we release a bug, we have like thousands of users, millions of patient records. It will affect lots of people. But it means each time it occurs, is it going to affect one person or is it going to affect lots? So an example of a multiple one might be we release a bug that totally blocks all documents from exporting. That, by its nature, will affect lots of people at the same time. Or we've transposed a certain identifier in the database. So suddenly everybody who was diagnosed with glaucoma is instead diagnosed with diabetic retinopathy. That would, by its nature, affect a whole massive group of people all at once. But most of the bugs we're going to talk about later are the sort of thing that would affect one record at a time. Cool. Any questions before I move on from this beautiful slide? No. OK, cool. Next one is likelihood. That's wrapped horribly, never mind. This is pretty straightforward. Basically, in the middle is it's possible. Could happen. Something like a 50-50 chance. And then either side, you get gradings away from that up to absolutely it's going to happen, down to really, really, really unlikely. This can be pretty hard. And as we'll talk about in a second, obviously, to do this, you really need to know what your user flows are like, what your real use cases are. To try and predict this can be quite tricky. And the more you know about your users, the more you know about how they're actually using the software, the more likely you are to get this kind of thing correct. So we take both of those things, come up with a number for each, then we use this lovely matrix and come up with a final score. So basically, if it comes out as a 1 or a 2, fine, can go out. If it comes out as a 3, oh dear, need to think about it. If we'd only really release a 3 if there's no way, we can't conceive of any way to mitigate that further in the design or in the way we do the system. And then we'd be giving advice to users with that release on how they should be mitigating to try and avoid that risk. So sometimes we release 3s, but with advice on how the user should mitigate further. If it's a 4 or a 5, nope, not going out. So that's how we grade, and that's how we decide, should we release it or should we not? OK.
So that leads us on to testing for clinical safety. So obviously, testing needs a slightly different mindset. So people might look at normal software. It's not really going to have any impact on anybody's life, whereas obviously this software is. So the ways that we do that, next slide, please. Mm-hmm. So we make sure that when people start new in the company, that everybody goes on site at least once to have a look and see how our customers are using the software. and make sure it's the right flows, but also make sure that they're not doing stupid stuff. Because we all know that people are not competent in using software. And this sounds horrible, but like the higher you get, so the more intelligent they get, it seems to be that they lose some brain cells when it comes to general knowledge stuff. Sorry, people that are really intelligent. No, but it tends to be that you've got surgeons and they don't want to waste their time clicking around, they don't want to waste their time doing this, they don't want to waste their time doing that. So they don't actually know how to use the software properly. They've not been to our training sessions, which becomes apparent when you send loads of videos over and try to get them the training and they haven't. So we then have to be like, you're doing that totally wrong, you need to do it like this. So we need to make sure that our system's idiot-proof, basically. And that's my mindset. I like to be the idiot in the room. So I like to be the one that clicks on stuff and does stuff. So it's very much experience on site with the customers, give you a bigger insight into what's going on and how they're using it and how we can mitigate them from making big mistakes. But we also do a lot of training and knowledge sharing on ophthalmology. So every year we have like a week-long training week that everybody can go to, and we get surgeons in from different hospitals who explain the workflows and what goes on in hospitals. And everybody's encouraged to go to those sessions. We also have like stock videos when we first start as well that are very much about ophthalmology and eyes and how they work. And the different kinds of diseases and everything else and the different kind of operations that can be done on them. So we get a lot of information from people that are ophthalmologists and surgeons to basically guide us in the way that we're testing the system. So we also then get input from the analyst team and the product managers, just to basically say, we think this is really high risk. So when we're testing that, we actually go to further lengths to actually do some kind, it'll go on to the next slide as well in a minute, do some kind of edge cases and things like that. So we look more into how we're going to use this, can we use it this way, will it break if we do this, if I put this information in, is this going to affect the patient in the long run? It could do, it could not, so it just depends what's going on. Next slide. Yep. So when we're testing, we write the test cases of patient-centric, so what information is coming from that patient and what needs to be in the system and what needs to be right for that patient to get the care that they need. That's how we look at it. We don't just look at it as the end user of the system, we look at it as how is that patient going to get the best care that they can get from the surgeon using our system. And we all have that mindset, and we also do exploratory testing when it comes to things. So we'll write test cases, document everything, but then we'll do a little bit of exploratory in that area. So when we're doing the actual feature work, we'll do some exploratory after we've done the test cases. So we've got us PBIs that are split up, you've done a tiny little bit of development. I'm going to test that via my test cases, and then I'm going to go, actually, I don't think we've covered every scenario that this surgeon who's going to click and do whatever they want is going to cover. So we then do a little bit of exploratory testing on top of that to make sure it's there. But we have got the documentation of the test case writing that we've got there. So if somebody went back, we can always say, we've tested it like this is how it should be used, it's there. So regression, we do at the end of a release cycle. We use automation and manual testing. More so automation as time's going on because we're making more of the manual test cases automated, but we still do a lot of manual testing because there's certain areas of the system that at the moment it just wouldn't be worth doing the automation testing because it is a user, and even though you can tell automation to do a few different things, you're not going to get the same experience of a user going, I'm just going to click this instead and that, but why can't I click there and then there? So there's loads of different scenarios, so it tends to be that we do a lot more manual at the moment, but it tends to be that we focus on clinical risky areas. So in our massive spreadsheet of every feature that's in our system, which is massive, there is a list of things that are clinical safety. So things that have been flagged already by the analysts or product owners, or when they've had their clinical safety meetings, it's been flagged as something that we need to test it every time, which gets repetitive, but if we don't, and something new that we've put in affects that, then we could be seeing catastrophic things happen. So we always focus on areas, but then we also do a little bit of testing around what we put in as well, and some general exploratory as well at end of regression. So we do edge case coverage. So even though we've got a set PBIs with a set ACs that we can think of, we do some edge cases just to make sure that if we are putting random information in, it comes out properly, or it tells the user, you shouldn't be putting that in there. So we have got like little pop-ups and stuff that say, please don't do this, please don't do that. Whether they listen to them sometimes is different, but if it's something serious, it'll be a case of, this is mandatory, you can't exit out of here without filling it in. Tough luck. Like, either fill it in or we're not letting you go any further in the system because it needs to be filled in. But yeah, obviously, as I said earlier, don't assume digital competence, training or common sense, because just because we tell them you should use it like this doesn't mean they use it like that. And even when they do attend the training sessions and they've sat there with people and we showed them how to do it, 2 weeks later, if you went back, I can guarantee they're doing it a weird way again, which is not the way they're meant to use it, but they find it easier. But as I said, we've designed the system so that if they do use it a weird way, it's not detriment to the patient.
Cool. What is it going to do?
Similar. So documentation. Yay! So because it is clinical safety and we have to have documentation and we have to have everything documented, we do need test cases written and test plans. So we have them in set folders of where the feature's been designed. We save them in loads of different places just in case. We have specifications, which is usually the job of the analysts and the product owners to actually put the specifications together, make sure that it's all there for when, if it gets released, we can give that to a customer and be like, this is how it works. Whether they read it or not is a different thing. We have backlog items, so just because we're designing something, it's not always going to be perfect. Nothing is. But there might end up being PBIs that we kind of just don't get to that functionality of the actual system that we wanted because we've run out of time. So it's not that important that they do get backlogged, but before anything is backlogged, again, clinical safety will be assessed on it. If it's assessed that it's a 1, we can live with it. Stick it on backlog. Eventually we might get to it one day. And same with bugs. So the bugs that we get, do they need to be included in this release? Is it a case of it's something tiny that a user looks at something, it doesn't look very pretty? Okay, we'll let it go because the functionality is there and it's not clinical safety risk. And then obviously we've got release notes and release hazard logs. So if there is, as Leah said earlier, if there's a case of there is a free, we'll then release the hazard log and be like, don't do it because this is what will happen. So there's a few instances of that because we can't do anything to mitigate on our side, which then puts the onus on the surgeons to basically do something on their side to stop things from happening.
Cool, thanks. I would also say when we're commenting on items we have to backlog with our clinical risk grading, write your rationale. You will kick yourself if 2 weeks later you come back to it and you wrote 4 and nothing else. Oh my God, I'm so angry with myself.
Bugs.
Yeah.
We do it with bugs as well. Like, we always document, we always write on bugs, yeah.
Do you want to talk about triage? We've got 10 minutes left.
Yep, I'll do it quick. So
okay.
Triage, so when bugs come in, this is generally in regression. If they come in generally when we're doing feature work, just fix the bug, like it's part of your feature work, you should have done it anyway. Sorry, my devs love me. In regression though, it's slightly different because we have to prioritise what we need to do and what for the release and what basically needs sorted now and what can be left behind. So we always do a triage on it and we always obviously assign some kind of critical, high, low, medium, low. So critical, it tends to be more like clinical data that's going to go wrong. So it's not really clinical safety, but we always assign some kind of severity to do with it. And then we will put a risk score on it as well, to actually say, yes, it's high severity and it might kill someone, let's get it sorted. But obviously if it ended up being low, that's when they get backlogged, because we'll do it sometime at some point.
Yeah.
But anything given it.
Yeah, in general it's about like empowering our testers to be able to make these decisions themselves, but also where there's any doubt or it's a bit scary or the tester decides it is scary, it's about Swiss cheesing it and having all these layers so that it means it won't get to production because it's run by lots of other people. Cool, okay, so examples, getting towards the fun bit. So wanted to run through a couple of these. Some of the biggest trouble we have with clinical safety is the fact that our system's used in lots of languages, and it is the same system that we translate, rather than being a kind of a totally different front end. It is the same front end translated, which we have lots of trouble with because it's very difficult to translate, especially clinical terminology, to make sure it has the same exact clinical meaning in that context, and also that the same words are used consistently throughout the system in the same ways. It's an easy way to introduce clinical risk. So we've got a few examples that were spotted before they went out. So cup volume is about the optic disc at the back of the eye, was translated to volume of the chalice in French, which sounds really, really exciting. It has nothing to do with your optic disc, so it was quite bad. Someone tried to translate paste, as in a cream, a medication, as copy and paste, that word, which didn't make any sense at all. Oh dear. This was a type of LASIK surgery that got translated as LASIK monastery because they read this and thought Presbyterian or something, not sure what happened there. Distance we have real trouble with. So a test at distance in the UK in ophthalmology usually means about 6 meters away. But obviously there are lots of different words for distance in other languages and they don't necessarily mean a test at 6 meters. So we've had to be real careful with that. Accommodation is your eye's ability to focus on an object, but it has been translated like pupil reacts to housing in our system, which, yeah, not helpful. So that's an area we have to be careful in. And then I have one that's not really about our system. It's more of a sort of a process failure, but I wanted to talk about it because a lot of the examples that we come across are to do with the way that systems talk to each other. In a hospital setting, there's often multiple systems, and there's a lot of risk involved inherently in moving the data downstream, upstream from our system. So in this case, there was a hospital where the majority of the ophthalmologists were using our system. The uveitis, which is a type of inflammatory eye condition, consultants refused and were just recording things in the central hospital system. Patient got diagnosed with uveitis. Their uveitis consultant wrote in the central system, absolutely do not operate on them. Do not do cataract surgery on this eye. It's inflamed, don't do it. The cataract surgeon didn't check the central system. They were just looking in our system where all of the ophthalmology records should have been, didn't see anything. They operated on that patient. Patient lost that eye. So it's really serious. This is why this is really important. This is why we take this so seriously. This is why it's so thoroughly embedded in all of our test practices and processes, because this is what can happen when it goes wrong. So what's the risk? Time for you guys to have a go at it. So we're going to run through some scenarios, and then we want people to shout out what they think the risk would be. We've got 5 minutes. That's fine. We can do this in 5 minutes. We've only got a few of them.
Yeah.
Ooh, do you want to try explain this one?
Yeah. So we have letters that are generated from our system. So when you've done an operation or some kind of consultation, it's got information in there. What happens is the system generates letters. However, what wasn't happening is the address wasn't updating for the patient. So obviously, what could happen? What's the risk of that? So it's basically the wrong patient address that's actually in the address field when we're trying to send information out to patients about either their operations, the eye drops that they need to take, or things like that. So anyone got any ideas about what will happen?
What would happen?
Yeah.
Yes.
I was meant to take a particular medication and then I didn't do it because you didn't tell me to,
Yep.
and something bad.
Yep, yep, in summary, yep.
Risk of missing your appointment.
Yep. So don't take your medication is a big one. Don't turn up for the appointment is a big one. You were supposed to book an appointment in somewhere else, a totally different hospital. You're supposed to book in an operation. Yeah, you could miss loads. Letters is a big one.
And what do we think was the risk?
Any resemblance to any other chili peppers is entirely coincidental. Anyone want to place on here? So we had sort of mild inconvenience. We've got like slight injury, severe injury, really bad injury you won't recover from, and catastrophic you'd only get to if it was that for multiple people at the same time. Anyone want to?
Yeah, extraordinary.
Okay, so I put this one at major because it wouldn't be multiple people. It would be one person at a time that would be affected, but it would be bad. If you didn't take your eye drops, you could go blind in one eye. That's about as bad as it can get. And yeah, definitely possible. Patient addresses change lots. So this could definitely happen and someone wouldn't notice. Oh, another
wonderful
one.
word of risk score. So risk scores basically determines on how soon they're going to be doing some kind of operation on the patient. So this lovely little thing that we developed was to basically feed through to the booking list, which goes through to reception. So you put a risk score in, the higher the risk score, the more likely you are that you need an operation sooner than anybody else. So if you've got, is it red that we've put on there?
Yeah.
If you've got a red risk score, then it means that you should get booked in before the other people. So
the bug was the risk score should appear like it does at the top,
Yep.
but it didn't. There wasn't no risk score at all. I mean, quite similar to what we just said with letters.
Yep.
But does anyone want to shout out what would happen?
Urgent care might not happen.
Mm-hmm.
Yep.
Correct. Okay, cool. So similar to last time, went with considerable rather than major. So it's not that no follow-up would happen whatsoever, which is what would happen with the letter situation, but it might not happen as soon as it should. There's usually, I put probability a bit lower because it's unlikely that this is the only system of checking this. Normally for any patient who's at high risk, there'd be multiple checks and there'd be reporting they would be doing as well to check that all of those patients are booked in. So a bit more Swiss cheesing going on, somewhere between possible and low. Okay, no one, I'm not being stopped, so I'll carry on. Okay, so this time I've got to explain some more ophthalmology to you. So before you have cataract surgery, you go get a scan that's called a biometry, and that measures loads about your eye, and that's used, all those measurements are used to decide which lens to put in your eye in the surgery. So we have an interface from the biometry device that pulls all those measurements in. In this case, it pulled in all the measurements you need to make the lens selection, so the encounter's fully populated, great. But there's a bit of additional information that's shown on the PDF of the report. So it's not the minimum, but there's some extra information. And the PDF came in as well. It's like nested, I don't know if you can see in the top left, nested under the biometry encounter, but you'd have to sort of select it to look at it. Can anyone hazard a guess as to any of the bad things that could happen if you, because of that?
You're not going to read it. Most people probably wouldn't look at the PDF.
Okay, yep, so people are not going to look at the PDF.
Does it come in cost if I think the report's not attached, I scan somebody?
Oh, yeah, so sometimes we get that. Biometry, probably not too bad, but some procedures are more invasive than that, and then, yeah, it is a cost to the patient if they have to redo that procedure or redo that scan. So actually this one, what I wanted to talk about was, it's not minimally required, but there's this thing called eye status, which you have to set on the device before you take the scan, and that actually affects how the measurements are taken. So whether or not they've had surgery before, for instance, affects how the device spits out all these measurements. So this wasn't in the encounter, but is on the PDF, and it's important context because if that's set wrong, all the measurements are wrong, and the scan needs to be retaken. So that's something where we made a change to make sure that that's now displayed on the encounter as well, so they've got that context for the measurements, and they can go, oh, oops, somebody set this context wrong, this patient has had surgery, I can't use these measurements, it needs to be retaken. Cool, I'll skip, and that's bad, but there's loads of Swiss cheesing involved there. I'll skip that. Cool, and I don't think we have time, do we?
You have a minute.
Oh, exciting, any questions? Oh, lots. Oh, God, okay.
One.
I think you were quickest, purple, maybe? Sorry.
Very quickly, do you tend to use mock data or obfuscate real data in your testing patient?
Mixture. So sometimes we get actual hospitals to send us test data over, but we make sure that it's got no patient data in there, so we're not doing anything to do with patient data. But they do send us stuff over that would represent what the patient, like the scans and stuff that the patients have had, or things that have happened to patients. We've also got a horrendous patient that's been going on for about 5 years that's got so much stuff on it, like it was backdated over the last 10 years, and that is kind of like a real life example of a patient and what would look like. And more recently we did one for you, Rory did one for you, and it was basically a massive load of data, but we did it so that so they actually represented what would happen with your visual fields. Yeah. So it's kind of like over a 10-year period, your visual field obviously would deteriorate, but we got like scans in that we could actually go over that period and you can see the timeline of it and everything. So it's a mixture. We input data and fudge data ourselves, but we also try and keep it as real to life as possible.
Okay, excellent, thank you.
Cool, and you can grab Leah and Tracy later on for some more questions, but break up all, please.